Hi, my name is Bill Herd, and I was an engineer at Commodore back in the 1980s. I just recently got a Christmas present in the form of a C116, which was one of my favorite computers I worked on, and it may have had a bit of a bad rap, and we're going to talk a little bit about that, and I'm going to show you a C116 up close. Now, the thing about a 116, which was called TED, and TED meant text display, and it was meant to be a business computer and not compete with the Commodore 64 and sell for $49. So it was the last computer that I know of, in my belief, that Jack Tramiel basically ordained or said, this is what we're going to do at Commodore. At that point, after that, Jack left. The 116, which had a 264, became the plus 4, and the 364, and the C16. I mean, it just spiraled out of control. But the 116 was focused. And to go back to where I was first introduced to the concept of the 116, Shiraz Shivshi, the head of engineering at MOS, and we were in the MOS building in King of Prussia, he showed me a Sinclair Rainbow. Now, this isn't a Rainbow. This is actually my old doorstop from when I was at Commodore. We thought it was great fun to use these as doorstops. And there's actually not a Z80 in this one because I tore it out and put it in the Commodore 128 the night we added that. We had to run around tearing open doorstops. But he showed me a Timex Sinclair, and this is what we were up against. This thing, this little black and white piece of crap, sold for $50. And he showed me the concept of the 116 and said, this is what we're going to sell for $49. It's got the chiclet keyboard, but other than that, it's a full-blown system. And it actually had 128 colors. The problem was 7 of them were black or 8 of them were black, so it actually only has 121 colors, right? It does have sound. But if you want, music with filters and everything, buy a 64. This doesn't have sprites. If you want to play games, buy a 64. Again, this was a focused computer, and it wasn't meant to compete with the Commodore 64, nor be a Commodore 64 in any light, not to be mentioned in the same vein as that. So let me show you the 116. Now, the very first thing the 116. And you can see the size of this thing. The very first thing that the 116 got a rap for, and the whole plus 4 and the whole TED family, was that the joystick ports weren't the standard Commodore joystick, and they're these little DINs. I hadn't even seen a DIN connector until I saw this. And I'll tell you that this thing is this is a piece of art, in my opinion. What you'll find is that everything about this computer, and we're going to look at it under a close-up here in a second, but if you look, that board's about as full as you can get. If you look at the back of that, that's about as full as you can get. The sides, the keyboard, everything was meant to be this size. And so the big Atari connector simply didn't fit. And again, you want to play a game, go buy a Commodore 64. So, and actually, I've got a joystick here. Rob Clark is a collector that was nice and sent me this, kind of my Christmas present here. He sent me a joystick, and he sent me a cartridge, which was the one cartridge we went to the CES show with, called Jack Attack, and guess who that's named after. So, the thing about the, let's go to a layout here, and I'll show you the 116 here. So the chiclet keyboard was the one thing we gave up, but for $49, we did leave room for the 264, which was going to be $79. Now guess what? You can buy an Arduino these days for $49. You can't buy any other computer with keyboard, with sound, with 121 colors or any of those things. You still can't buy them these days. So it was ahead of its time, I think, and again, being fairly focused. And the 264 was supposed to sell for $79. And again, for a business machine, that TED was the name of the chip, meant text display. Everything about it was meant to be business. Now, of course, Commodore lost its way at one point. The people in marketing and whatnot couldn't tell the difference between the success of the Commodore 64 and this new machine called a TED, so they tried to turn it into a 64. I think they ended up charging $349 for it or something like that, putting the +4 software in it. Recently I heard somebody said that guy, he's like, hey, my software is getting a bad rap. And that's a fair enough statement. I don't know anything about the guy or the software other than I knew it wasn't worth $200 and it wasn't worth what it did to the computer. It probably is good software. We've never used it. We just saw it as an add-on later. And it was me that put those sockets there, so I got rewarded for putting those EEPROM sockets on there. So here's a 116. And this is going to be the one that I actually show my son and say, hey, this is what your daddy used to do. Again, there's a lot of art going on in here. This was the first year that 64K DRAMs came out that were available in a 16x4. So up until then, if you did a 64K DRAM, it was 64K by 1. It was 8 chips. Well, suddenly we've got these 2 chips that are by 4 architecture. And the poor guy from the local representative, he was beside himself when we said we're buying 1 million, and then later he figured out we meant from the Hong Kong branch. So we had to write a letter saying, yeah, this guy helped us out. But if you look at this, there's some interesting things. These ferrite beads that are everywhere, that's me. I'm big on RFI and EMI, and in fact, if you see this diameter hole, this 3/8 hole, I may have learned it from this, but that hole ends up to be not an aperture at the frequencies we talk about, so we can let airflow and heat out and not let the frequencies spray in the frequencies that we were concerned of back in the old days. So, but some interesting things popped up. There's this big power resistor here that's in parallel with the power regulator, and power regulators are kind of nuts to try and design for, because you have to develop for a minimum current and a maximum current, and the minimum and maximum voltages that could come from the power supply, and sometimes it's almost like you're throwing away half the design just for the worst case. Well, this came back from the Japanese office with the resistor in parallel. And what it did was it said, well, we know you're always going to use a certain amount of current, and the power resistor actually took care of that. And the regulator took care of just the last little part, keeping it in regulation. So I remember I grinned at that, and I learned a dirty street trick that day, and I've used it since then to keep the regulator itself cooler by offloading it to another device. We've got a custom 6502 in here called the 8501. It started out as a 7501. It's basically a 6502 processor with a flip-flop on it, and maybe a few other things in the R0 gate. And I could tell you an interesting story about the day we tried to turn that up, but we'll come back. I'm going to do a second video on stories here. This is just kind of a quick tour. And when Jack had done this, he had said, look, there's X number of chips, and this came down the mountain quite literally through the engineering team, through Shiraz. And the design of this was essentially done by the IC group, because the TED chip is so instrumental in the design of the computer that the hardware engineers, we were kind of along just for the ride. At least that's the way it was when I first got into it. And so, I mean, it's a single chip system, and it was dang close to being the first single chip system like that. So there was this thing that said you can add chips. I think it was 8 or 9 or something like that. And eventually I showed that we actually needed a reset circuit. And I knew this because I'd worked at a company called Pennsylvania Scale Company. It did our own battery backup. And I learned how to make things fail by getting the voltage right at 101 and then dropping in and out of areas. I could screw up almost any computer of the day. Well, sure enough, I screwed the heck out of this one. So I petitioned to put a 555 reset circuit in there. And actually, and I believe that's it here, is when that happened, people thought I might get fired. And at the end of the day, I didn't. You know, the ground didn't break open and swallow me whole. So at the end of the day, what it was Jack had made people do it in the least amount without a lot of overkill. But at the end of the day, I don't think he really cared about the exact number. But his point was, we got to keep it so we can sell this thing for $49, and that's what he did. So I'm also showing the website there. C128.com is my website. This video, I'm going to post some pictures of the 116 and some of the other things that Rob Clark was nice enough to send me there. So the other thing about the other chip I had to add to the 116, almost called it a plus 4. There's an MOS chip over here, and it's a 8-bit port. Now when I got the 116 design, I carried the schematic around. There was no excuse for what I overlooked, is what it comes down to. Then one day, and I'm going to tell you what we overlooked. One day, we get these black spots on the screen when you have a joystick plugged in. Joystick. Plug it in, black spots on the screen. So I'm sitting there, I'm looking at the schematic, and I start laughing. And the bottom line was, the data lines were used to scan the keyboard right out of the processor, right over to the keyboard. And that's a mess. I mean, there's changes in impedance, there's radiation, there's a dozen reasons not to do it, and I missed it, right? I took it at face value, and on the schematic it looks nice and clean, and to a chip designer it would have looked nice and clean. But it got even worse because the joystick port had a data line running to it. Well, you can't drag a data line down this thing. You just can't. That's not, especially not the frequencies of the day. And so it was blowing up the video data, and so my hunch was it probably blew up the processor data, and sure enough, you'd take one of these, put it up to a monitor, and bam, it would crash the thing. And I'm standing there, and when I realized I had missed it, I started laughing at myself. Because it's like, all right, I got to fix this. Well, my boss at the time, Joe, who I got along with, he was, I think we respected each other. But there was 2 times when I worked for him where he threatened me with my job, and this became one of them, where he wasn't amused that I was amused, and he's like, fix it or you're fired type thing. So fine, I'll fix it, bottom line is, he walked into the lab 2 hours later, and I'm standing there with my joystick, and I'm playing a video game. Now, a lot of people at Commodore played video games, and it looks like I'm doing the same thing. And he got a little ragged, and he's like, you told to fix it. And I just pointed at the monitor. I didn't say anything. I pointed at the monitor because there were no speckles on there. And he didn't get it. And he got a little madder, and I just pointed again, and he got a little madder, and then finally I hold up the cord of the joystick. What I'd done is I'd had a technician put a 20-foot cord on the joystick. I had taken the case off of the monitor and wrapped the joystick cord around the yoke, that very scary coil-ish thing right on the high voltage of the picture tube. I had wrapped it around the most noisiest component you could imagine to prove that I had fixed the problem. And finally he got it, when I pointed like for the 4th time. And what I'd done was I had added a chip. By now it's like, we got to fix it. And what I did when I'm picking, there was 2 criteria I did when I picked that chip. The first was I didn't want something hard. Like a TTL, like a bus driver, like a 244, 241, 245, one of those things. They're too hard. The keyboard would ring like a bell. It would emit. This thing has all kinds of different lengths of wire, and each different, it's like chaff, when you drop for radar. All the different lengths of wire in here would emit at different frequencies. The other thing is so hard, it gets hot, and if it shorts against anything, it'll blow itself up, catch fire. Ask Greg Berlin about that. Some of his burned up at a CES show. So I wanted something soft, like an I/O chip. And I knew that we had, at MOS, of course we made our own NMOS stuff, we had a single port chip in the data book. And I liked the idea of our own chip because we could control the quantities. This was back when you didn't dare get caught missing an LS chip, and then there was these shortages on LS that would run through stuff, so I had to use regular TTLs. I mean, it's just, I designed for what was in stock. And actually, at one point, I pulled the stock from the Japan or from Hong Kong office or Taipei, and I designed according to what was in stock. We had 2 million or something. So the idea that I think we were the only customer for the 8529, but so I put in a softer NMOS chip that we made, and that was acceptable. And what it did was it buffered it. So we happened to have I sent downstairs for one during that 2-hour period. So that was one of the quick joystick stories. I'll tell you the other joystick story here, and then we'll wrap it up. The designer of this, his name was Ira Vilensky, and Ira's passed away. I understand from Leonard Tramiel. He passed away coming back from a CS show, and he died young, and Ira was a friend of mine, and I was very upset to hear about his passing. But Ira brought this design. Ira had designed the DEC Rainbow while working at DEC. Somebody else mentioned their company that he did, but so this was Ira's look and feel. You see the angles in here, and he was behind the switch of the port and everything. So he basically gave us this package and the coolness of this design. I think this was ahead of its time for that kind of design. Well, one day he'd come to the offices in the States, and he had brought some different things. One was a joystick port. And he had what was called a soft tool, and that cost like $20,000 to make. Essentially what they would do is do things like carve wood and then or some other compound and then pour plastic on it. Well, if you look in here, there's a real thin little neck in here. And Ira liked that a lot because it looked designed, it looked futuristic. And I looked at it and I saw something that was going to break. And Ira didn't agree with me, and we're sitting in a meeting. Now, you got to understand, back in the days, I was long-haired. I've never been to school for electronics. I've taught myself everything. So I had a presence that I had to keep up. I had kind of a reputation. I was wearing shoes that day, is the good news. So Ira said the fateful words that said, "It won't break under any condition," which gave me permission in my mind to check it, right? If he said, well, you'd have to abuse it to break it, that'd be different. So the tension went down to the far side of the table as they go on to the next subject, and then you hear snap, and you look over, and I've broken the joystick, and I'm like and pushing it to the center of the table, and it broke right in there. Now, honestly, it took a little more effort to break than I thought it would, but I still knew that I was doing something by breaking it. I was proving a point, and it did get made thicker with some reinforcement and stuff. I broke a $20,000 joystick to prove a point. And I was, Ira wasn't mad. I mean, he took my thing. He did teach me some Japanese that got me in trouble later. So I had to learn to check whatever he taught me. I had to verify with Ray or somebody. So, but that was the story of that, where I should have been fired in other companies or something for just ruining $20,000 right off the bat. But no, not then and not this place. So this is the 116. Again, it was $49. How can you beat that, right? That was what this was supposed to be. It was supposed to be a business machine. It did have a cassette port. People like Hedley Davis had to chime in to do it, to make it work right. I mean, that dang cassette port. And of course, the people that worked on this were Freddie Bowen and Terry Ryan. Fred did the kernel that's in this, and this was the first one that had a built-in ROM monitor. We could actually disassemble our own work while working, and it was excellent. We actually got a telex from Gail Wellington, the head of Commodore UK. It said, "You've now created the perfect machine for piracy." And I sent back a telex, one word said thank you, or 2 words said thank you. And then Terry Ryan gave us the basic. There's like 3.5 or something in this, where he gave us structured basic. He got in trouble for it, but the loop while, do untils, all that kind of thing. So that's those two. I took over the design. Again, this had floated around various hardware engineers before I got it. So I didn't design this. This, again, was designed mostly by the chip designers, really, if you come down to it. But I kind of nursemaided it through. Dave Haney was on my team that did that, and then we got to the Plus 4 series. And, we did get some interesting detours. There's a thing out there called a 364 that it talked. And we had the TI Speak and Spell guys, Dr. Richard Wiggins and Tim Brightman. had done that from Commodore, Texas. And, it was a real honor to meet and work with those kind of people. And it was an interesting thing to do. I don't know if it had a target market audience, but typical Commodore fashion, we put tremendous effort into making a talking version of this and then didn't sell it, right? So didn't sell this, right? Because I think we tried to charge $200 for it, or we made it into a C16 or something. This one's a PAL version. I noticed it's got like a some kind of European symbol here. So again, let me see if I can throw up the website here. I'll have some pictures here of what Rob Clark sent me. And again, anybody else has any old computers you have questions about, you want to send me pieces of. Again, I didn't even own one of these things after all these years. I had just a cover. And I was feeling kind of sad when I mentioned it to him, because I was like, I wanted to show my son what this PC board looked like, because again, I thought that was a work of art. So yeah, catch me at c128.com. Maybe we'll turn into some other retro computers. You ever have a question wondering why the heck we did something like the way we did? Go ahead and ask. Maybe the answer is we didn't know any better. So have a good day.